Good afternoon, everyone. It was excellent lunch, wasn't it? So this afternoon, the National Center for Timber Durability and Design Life, I'm the director of that. And today the team will go through some of the work what we have been doing in the timber circularity space. So what are the project actions and outcome for the circular economy for Australia in treated timber and engineered wood product in specific? So the whole session will be covered by us. Penny will introduce why circular economy matters, and then Mel will talk through some of the resource mapping that has been underway. This is, by the way, world first. And then Zidi will present some of the work, what we have done on the characteristic of some of the resources. And Martin will discuss some of the pilot, what we are planning and what we have planned for future. And then I will just wrap that what are our plans for the next few years. And at the end of the session, we will have time for panel discussion. So if you could just use your phone and scan the QR code, you will be able to send some question, and we will take those during the panel discussion. So I will give you a moment. Let me know if it doesn't work. Cool. So the Timber Circularity Project is a national project hosted at the National Center for Timber Durability and Design Life. And it's mainly industry initiative, so funded via industry and matched by FWPA. So some of the key industry players involved are Forest and Wood Product Australia, Wine Australia, FPA, EWPAA, Frame and Trust, Manufacturing Association of Australia, some of the chemical and glue companies like Azelis, Coppers, and Hexion. The focus is that what to do of these timber at the end of their life, like CCA treated timber, like frame and truss offcut, engineered wood product, or utility poles. How we can use them in the value chain so they can still be reused and recycled at the end of the life. We have 7 distinct tasks looking at the value and geographical location of these end-of-life products, and at what condition these products are. Can they be reused, or do we need to process them before reusing it? What are the regulatory hurdles or enablers that we can use them? Because each state of Australia have different regulatory requirement when it comes to the end-of-life products. So understanding that has been quite challenging, and Martin will take us through a little bit about that. Then we have mapped what are the opportunities and what solutions currently are and what is in future. All of these information has been mapped in our geospatial mapping. So if anyone wants to use that in a certain location, what resources are available, what solutions are currently available, what are the potential, all those information is on the geospatial mapping. And our most important task is to have some pilot where we can demonstrate what we can do with the CCA treated timber at the end of the life. So I will pass on to Penny now. Penny is the project lead for this project, and she will go through why circularity matters.
Thanks, Tripti. Have I got my mic on? So as Tripti mentioned, I'm going to be talking about why timber circularity matters. So the Timber Circularity Project actually stems from the challenges with end-of-life timber, which Tripti mentioned. It's hard to fully understand how much waste or timber waste we actually have in Australia, because it's included within the organic waste stream under the national reporting strategies. But we estimate about 2.5 million tonnes of waste annually. So we're depleting resources while simultaneously generating waste which could be reused or recycled to replace those virgin materials. Again, as Tripti mentioned, the regulations currently restrict cycling timber or treated timber and engineered wood products specifically back into the supply chain. And most of this waste is ending up in the landfill at the moment. But the thing is, preservatives and wood treatments and adhesives actually add value to our timber. They extend the life and utilise underutilised resources as well. But obviously they cause the problems at the end of life. So if we can extend the life of timber products or enable products to cycle through multiple lives, then we can have very big benefits, not least meeting the Australian government's circular economy remit, which has actually been extended to 2035, but we won't talk about that. I'm sure most of you are aware of the timber circular economy. This is our little mud map. It's probably not very easy to read because it needed to be quite large. But it enables resources to re-enter the supply chain at multiple areas, particularly keeping them at their highest level is important, but cascading them through reuse, recycling and recovery. And there's many stages along the supply chain where there are opportunities to apply these circular economy principles. But they also fit within a hierarchy of use. So we're looking at repair and reuse at the top of the hierarchy. So an example of this is our pilot project that we're doing, which is which Martin will be talking about, but is a vineyard posts end of life being used as fence posts. Remediation, there's nobody that does that at scale in Australia, but we have been talking to people that have technologies to remove those heavy metals. The heavy metals can be reclaimed and the fibre can be reused for particle board or energy production if necessary. Recycling chipped wood. So particle board is obviously a product that would suit that well. There's regulatory restrictions against that at the moment as well. So these are all things that we need to consider, but hopefully we'll get a pilot up for that. Pyrolysis is also a growing field and it's quite an exciting area in Australia. We're looking at doing a pyrolysis and gasification pilot if the project gets extended. And there's also targeted research into composting and exploring biological remediations. And finally, although energy recovery is the lowest on the hierarchy. It does obviously replace fossil fuels, so there's merit in energy recovery. However, just because all of these exist, it doesn't mean that they're the best opportunity for the location. So there's a lot of other considerations that we need to consider in what we do with our end-of-life timber. And there's a list there, but economic considerations is obviously quite a key one at the moment, but ecological, technical, where it is, because distance is pretty much one of the major challenges in Australia. Moving resources around is, it just adds emission and cost burdens to any new product or process, often making them not viable unless we do it at a regional level. So that's where the mapping comes of import, because we get greater understanding where the resources are located, what types they are, how much, and then we can better understand what opportunities there are for reuse. In addition, we need to better understand that wood resource before we use it, so we can understand how it can be reintegrated. So Zedi will give us a bit of information about that. So the mapping and analysis of the resource really does help us identify the most appropriate circular solution, and start understanding our capabilities and what infrastructure we may need in the future for a timber circular economy. Which really brings me to why timber circularity matters, and we've already seen a few of the SDGs that relate. When we're looking at a timber circularity, there is actually a lot more, and we know that forestry is important, and I think that 3, 6 and particularly 15 are very important there. And I don't have time to go through all of these goals, but just a few that the timber circularity tick. In nature, a circular economy will be regionally based, so it will strengthen regional economies, enhance resilience in those areas, and create green jobs in sustainable sectors of the economy. Also based on sort of the more innovative models, service, repair, and reuse and recycling. We'll have to look at innovative solutions that provide meaningful work and opportunities, and those things all align with 8, 9 and 11. And also a circular economy will encourage sustainable consumption and production patterns by reducing requirements for virgin fibre, minimising waste and maximising resource value, so we keep materials in the supply chain for as long as possible. So that upholds goal 12. So the timber circularity resource map is really helping us connect those unused timbers with reuse and recycling opportunities. A couple of others. The circular economy will help us mitigate climate change by reducing greenhouse gas emissions, sequestering carbon, long-term storage if we cycle through multiple product lives, and then if we do look further into the bioeconomy, things like biochar will store carbon long-term, and these things will help make the most of that forest resource. And finally, a new circular system will be built on extensive collaboration. So industry is working very closely with us, research organisation, government agencies. The Timber Circularity Project really is an example of this at the moment, providing a link between industry, government and research, and serving as a platform for knowledge exchange. So as a bit of an example, this is a case. We're doing several case studies, but we're just finalising some of them at the moment, and they strongly reflect circular economy principles. So these case studies help industry understand not only the potential, but also economic returns that are possible. So we're generally at this point focusing on engineered wood product case studies that have little waste due to a closed loop internal system, such as Laminex's MDF facility just up the coast a bit. And we're also focusing on engineered wood products that accept waste resources from outside their companies to turn into new high value products. So Borg's particle board and mega beams glulam, for example. So we've mapped them out based on their challenges and the solutions that they've come up with, the circular economy principles, and also the strategies that they've used. And in terms of industry, I know Lyndall said that lots of people didn't really like the circular economy, but that's probably in the forestry because of the other industry along the supply chain. It's actually of real importance because on a survey that we just did of users of engineered wood products, you can see over 50% respondents said that they wasted up to 10% of their resource, and 96% that said that they paid to get rid of their waste, and 5% of those paid for recycling. So most people are paying something for recycling, and as you can see, the disposal costs are pretty significant. So some facilities are paying nearly $7,000 a month. Lots of people are paying a lot more than this, but these are averages. So with these types of figures, industry can fairly quickly see that it makes sense not to be paying to dispose of this waste. Interestingly as well, some people were only paying for transport. So they weren't just paying for the disposal, somebody was taking their waste, but they still had to pay a significant amount for transport. Borg as well, they take end-of-life timber, but they actually charge gate fees or charges to have that collected, and it will cover their processes. Megabeam, who's just in Caloundra, they actually collect their offcuts as backloads, and they don't charge, but it's a win for them because they get free resources, and it's obviously a win for the people that they take the resources off, because they no longer have to pay for disposal. So just to conclude, we think the Timber Circularity Project is contributing tangible progress towards a future where all end-of-life timber, including engineered wood products and treated timber, are considered a resource rather than a waste stream. Our project is quantifying and assessing resources, analysing logistics and regulations that enable or challenge circularity, and demonstrating opportunities for this end-of-life timber. So I'm going to now hand it over to Mel because she will be introducing you to our resource map.
Thanks, Penny. Can you guys see me okay? Yep. All right. The purpose, as Penny mentioned, just going through a quick overview of the map and just some of its features. So the purpose of the map is to provide a link between unutilized or unwanted timber resources with potential solution providers that are able to repurpose or recycle it into new products or energy. We've done this by plotting data collected from surveys, site visits, public records, and industry discussions. The live map can be accessed through our Timber Circularity website, which is noted up there. And on the website, we also host a range of other project outputs, including our reports, project updates, live webinars that we've done, as well as I've done a user guide to explain details of how to use the map effectively. So far, we have mapped treated timber resources from utility poles and engineered wood product offcuts. We have also mapped unwanted or removed posts from vineyards and frame and truss offcuts, all of which are represented by those the two icons, or the first three icons, sorry, from the top. if the project continues beyond our current timeline, we also aim to map construction and demolition waste and potentially even forest residues that could be utilised as biofuels. In addition to these timber resources, we have map solutions that are represented by the green icon. Solutions are facilities that can be utilised, that can utilise unwanted timber products and include renewable energy producers or composting facilities, but we're still expanding on that at the moment. Engineered wood manufacturers are also mapped, as Penny mentioned, that were the most recent, as a solution, as clean, uncontaminated offcuts can be utilised in the manufacture of new materials. So we have included circular economy infrastructure, like councils with prominent circular economy initiatives, as well as transfer stations and landfill sites that can manage treated timber. So while these last two are not ideal solutions, in some states they're the only viable option at the moment. So each facility, so the ones I just mentioned, the circular economy councils are the orange, and the two blue ones are the other end of life at the moment. Each facility is represented by an icon at their location, or sometimes for data privacy, we have mapped the facilities by their postcode only. Users of the map can click the icons and relevant data is provided in pop-ups. So for example, by clicking on a vineyard post icon, provides data, a range of data like number of posts, volumes of posts, and number and volume of unwanted timber posts that are available in that region. This frame and truss over there, frame and truss data was accessed by clicking on a frame and truss icon, which are the pink ones. This pop-up, or the pop-up, provides information on the size of the facility, the average volume of wood resource available, what type of resource it is, the percentage treated, which varies by state, the treatment type, and the condition and potential for separation, as well as our assumptions and any associated reports that we have produced about the data set. Each resource is mapped on a different layer. So if you're searching for a particular resource or solution, all other layers can be turned off. So in this case, I have switched on just the frame and truss resource, which again are the pink ones, and the solution's still there as well. And this allows you to search for a specific resource in that particular area. So you can just use the search bar. The map also allows you to find resources or solutions within a defined radius using the near me function. So in this case, I use the default 100-kilometre radius, which we found to be a reasonable distance in terms of cost and emissions for transporting resources. All the data from the search that you do can be downloaded into a spreadsheet, and then you can sort the data as you see fit. So depending on what you're looking for, so it can be sorted into, say, facility size or distance away or a range of other parameters. The map is being regularly updated with new data. So our most recent added layer was the EWP secondary processes, represented by that maroon icon. This layer includes end users of engineered wood products, such as kitchen and bathroom manufacturers, shop fitters, bathroom cabinetry, that type of thing, and the average percentage of unused materials available. We have received very positive feedback from industry and government about the map, with some key players mentioning that they have found it useful. Laminex mentioned that they have used the map to explore further resources near their particle board facility because they wanted to increase recycled wood fibre into their operation. A keynote speaker at World Conference on Timber Engineering used the map as an example in her presentation and said that Oricon is using it at the moment. The map has also been presented in conferences overseas, and we have received similar reviews. We hope to obtain additional support so that we can continue to add new layers and update the data, as this is a critical step in achieving a timber circular economy. An important consideration is understanding the viability of used timber. And on that note, I'm going to hand you over to Dr. Zidi Yan, who is going to talk through some testing that we have been doing to better understand the condition of used wood and how they can be potentially reused. Thank you.
Hello, good afternoon, everyone. Can you hear me? Your mic's working? Cool. My name is Zidi Yan. I'm the postdoc research fellow at the Tripti Center. And as Mel introduced, today I'm going to talk about the chemical and structural testing for the vineyard posts. So as Penny discussed why a timber circular economy was so important, but I would like to expand on that by exploring the Ellen MacArthur Foundation's butterfly diagram, and which separates the biosphere and technosphere. And conventionally, timber building and structural components have been viewed only within the biosphere. But the CCA treated timber vineyard posts, which are one of the focus resources for Timber Circular Economy project, and fit within both the technosphere and biosphere, making it more relevant to keep the posts circulating within the larger technical loop for as long as possible, and positionally enabling multiple lifetimes of reuse and recycling rather than early disposal or landfilling. And to achieve this, it must first understand the resource's remaining capacity for reuse, including the chemical retention and the structural strength. So that we want to determine how it can be safely and effectively reintegrated into the supply chain. And now I will start with the chemical analysis that our team conducted earlier last year. We tested and studied 48 aged timber posts that have an average service life of 18 to 28 years. And we collected them from 6 vineyard posts all across from South Australia. And these posts were directly transported to Brisbane for chemical and structural analysis. And by using the XRF technology, our team analyzed the retention level of copper, chrome, and arsenate within the timber. And each post was cut into 4 sections along its height to the ground line and to the butt. And each segment was assessed individually to understand how the preservative chemicals were distributed along the post. And this table here compares the remaining CCA composition across 6 vineyards in South Australia. And the first thing to note is that most samples retained around or above 0.6% of total preservative, which is the Australian standard AS 1604 indicated that it's the minimum level of H4 timber should have. And we confirmed that the preservative system has stayed chemically stable even after more than 2 decades of use. And the only exception is the vineyard E, as you can see from the table, as I highlighted in orange color, where the arsenic levels are not noticeably lower. And this could reflect either slight leaching over time or unbalanced treatment mixed at the time of manufacturing. And this bar chart shows the CCA retention levels across 48 samples, and each bar representing an individual post. And the dotted line marks the H4 retention threshold of 0.6%, as I mentioned before. And as you can see, most samples reached around or above the standard, and demonstrating that even after 18 to 20 years service, this post still retained enough preservative to ensure the long-term durability. And on the right-hand side photo, you can see that the cross-sectional cuts of the post that was spread by the chemical reagents And the blue stain clearly shows that the sapwood region were fully penetrated, and there was also some evidence that the hardwood was penetrated. So to conclude the chemical analysis part, the average CCA retention was ranged around 0.35 to 1%, and most samples still meet the AS1604 H4 in-ground timber standard. And the copper, chromium, and arsenate remain stable and shows only mineral leaching over time. So in this part, the conclusion is that these averaged vineyard posts were well treated and chemically stable, which means this can be reused in H4 application and to support the circular economy practice and in the viticulture sector. But this also brings up another question, that what about their remaining structural strengths? Can they still be using for the structural purpose? So the next part, I will talk about the structural analysis. So we want to assess how much the structural strength remained within this vineyard post after 20, 30 years. And in total, we tested 20 vineyard posts, 10 old ones and 10 new ones. And the test would follow the X4063 standard with a 4-point binding test, and to measure the key mechanical properties such as the maximum load and the displacement. And we are using those values to get the maximum, to get the modulus of electricity and rupture. And those two variables are determining the stiffness and the bending strength of the timber. And photos on the right-hand side shows the UQ lab team that conducting the full size bending test is using the Australian standard proposed. Here are the results from our structural test. The maximum load was dropped from 32 kilonewtons to 20.5 kilonewtons, which is a significant drop, around 36%. And for the MOE, which tells us how stiff the timber post is, went from 10.4 gigapascal to 8.7, which is not that a significant drop, representing 17% decrease. And the MOR, on the other hand side, represents the bending strength, showed a bigger drop, around 78 megapascal for the new ones, and 55 megapascal for the old post. And this is roughly about 30% decrease. And when we run the statistical analysis, the stiffness difference wasn't that significant. But on the other side, the strength reduction was actually very significant. And on the right-hand side photos, you can see the failure mode of those old timber post and the new timber post. And the most representative failure mode was the cracks on the around the knots. And there is also, and there is also no difference between the old and the new post, and all the failure mode typically happens around the knots or the middle span. So to conclude this presentation, the maximum load drops from, To conclude this presentation, our results show that this reclaimed vineyard posts still have adequate strength for lower stress applications. And they are particularly suitable for things like fencing, edging, landscaping, or temporary bracing. And where those applications, the strength requirements are not that high. In fact, many of those old timber posts, still exist the F7 structural strength requirements, which is impressive considering this timber has been in use for 30 years. And reusing this post not only supports the resource recovery and waste reduction, but also helps to promote the circular economy practice within the timber and viticulture industries. And moving forward, we also recommend a larger scale testing and species identification to refine the data and confirm these findings across a wider sample, and using other techniques to determine the structural strength for other timber materials as well. And so the key takeaway for this presentation is that the retention level of the chemicals and remaining structural strength of the vineyard post has make a reclaimed vineyard post a practical and sustainable option. and especially for engineers, architects, and landowners who are seeking for the cost-effective and environmental responsible solutions. And now I will pass the floor to Martin to talk about the next part of this presentation. Thank you.
As previous speakers have said, I'm going to talk about the pilot project and a bit about the regulatory environment. So I'm going to give an overview of the size of the vineyard resource, some alternatives to landfill, which others have outlined as well, some barriers and enablers to being able to divert the posts away from landfill, and then an overview of the pilot. Start off with, most of you are probably not aware, I certainly wasn't, that up to 4 million vineyard posts, this is treated posts, reach the end of their lives Australia-wide annually. 8 wine regions account for about 80% of the posts removed nationally. And we've estimated that there's over 30 million posts currently stored in stockpiles on vineyards around Australia. That's a very rubbery figure, but it's probably in the right ballpark. Alternatives to landfill, circular economy point of view, repairing the posts or reusing the posts are the best options. And that's because that they, for a circular economy, you're trying to keep the material in the highest value use for the highest length of time, keeping them intact rather than chipping them or burning them obviously gives them an option to continue in the circular economy. Other options, Penny outlined some of these. Particle board, I just wanted to make the point, I'm specifically talking about here the vineyard post, but it does apply to other elements of this project. But the particle board, one of the things we thought about is that in Australia, I think the consumption is over 1 million cubic metres of particle board a year, whereas those posts that are pulled out every year in Australia is like 15,000 tonnes. So there's enormous differences in order of magnitude there. So what we're thinking is that we could put in what to the wine industry is a big amount of posts, maybe a couple of thousand tonnes. And if we spread that across a whole lot of particle board, you actually are only going to get the concentration of those CCA substances at a very low level in the particle board. Pyrolysis, Penny mentioned that. I suppose the issue here is, just to talk a bit more about that, is that the if you know anything about pyrolysis or burning CCA treated timber, arsenic is the problem. Arsenic volatilizes very easily. But what we found is that, just from a literature search, is that if you do pyrolysis at a low temperature, under 400 degrees Celsius, almost all of the metals, including the arsenic, are retained in the ash as metals, and there are techniques which you can use to actually separate out the biochar from those metals and potentially reuse both of them. Finally, cement kiln fuel. Theoretically, you could use it in waste to energy, but the problem is that the waste to energy plants would have to put in place all of these mechanisms to try and control the heavy metal emissions. Cement kilns already need to do that. Cement in the raw materials and in the fuel, if they're using coal, actually comes in with a lot of heavy metals. So it seems like an obvious solution for the CCA treated posts in places overseas, including New Zealand. They actually do put in thousands of tonnes. In Australia, there's the regulatory environment is such that just using the precautionary principle, they said, well, if you don't put those more heavy metals in, then you're not going to have to worry about them down the track. But what the research is showing is that the amount of heavy metals that comes out is pretty much independent of, airborne emissions, is pretty much independent of the concentration going in, which seems a bit counterintuitive. Another thing I didn't know about cement kiln is that most of the heavy metals, like 99%, is actually bound up in the cement matrix. And it's already happening. And if you put the CCA timber in, it would just incorporate those extra heavy metals. Again, there's an order of scale. You're not going to replace all of your fossil fuels with CCA timber. So in the context of the amount of fuel going into a cement kiln, if you collected all of the CCA treated timber in Australia, it would only be like a drop in the bucket. So that's some other alternatives. Barriers and enablers. Chief barriers I've touched on is regulatory. Basically, most of the environmental protection agencies in Australia either specifically exclude, sometimes they just lump all treated timber together and say, just treat it all as the same in terms of regulations. Sometimes they specify out CCA treated timber, but basically the idea that you get is that the preferred option is for it to go to landfill. And I suppose the other element is the regulatory could be supportive, and at the moment it's not. They're all supportive of a circular economy, except when it comes to treated timber. Economic, and some of the other speakers have touched upon this. The biggest problem, I suppose, if you're looking at it from a forestry perspective, saying 15,000 tonnes and spread across all Australia, that's not going to be very economic. And that is one of the biggest problems. The biggest problem is, from a forestry point of view, with forestry eyes, they don't have a big problem. They've got a lot of space in between those stockpiles of treated pine posts. Enablers, the biggest enabler is landfill waste charge. And I'm sure it's no coincidence that the treated timber landfill waste charges have been set quite high to try and encourage diversion from landfill. I can't remember the exact figure, but we did a bit of a ring around, Mel in particular, and I think the median figure for Australia is around $250 a tonne. So you think if you're 15,000 tonnes, you're looking at millions of dollars a year if you wanted to send it all to landfill. So that's a big incentive to not do it. But as you've heard from what I said earlier, what that has created is an incentive to stockpile it. Stewardship scheme, it's still a work in progress, but you'll be familiar with stewardship schemes where for other materials where you just put a couple of dollars onto the price of the new product, and that covers costs down the line for reuse, recycling, disposal, or whatever. But it's not there yet. Okay, I just wanted to touch on post-repair, because you've been thinking, well, you said post-repair was a good thing, why aren't they doing it? The cost of the kit is similar to that of a new post, but it has a lower installation cost. And you can see in that picture the metal structure against a post. It's rammed into the ground and then screwed to the post. And that's fairly quick. You don't have to remove the stump of the old post, and you don't have to detach and reattach the wires holding up the vines. So that's the advantage. Disadvantage, obviously it's only worth doing if the broken post is still in good condition and if the breakage is near the surface. Most of the time it is, because the breakage is caused by mechanical harvesting. The machines beat the vines to get the grapes off, and of course the point of that it's bending around is that point at the surface. What I think is happening, though, is the vineyard owners are thinking, well, we've got to go to every post anyway, because we don't know if they're in good enough condition to repair. So maybe if we've got to go to them all, it'd be a better long-term solution to install new posts. That's just my guess about why they're pulling them out. Okay, so the pilot, as others have mentioned, it's about reusing as fence posts. And I suppose the key thing is it financially viable to establish a business reusing vineyard posts as fence posts? We're looking at the pilot in South Australia. Key elements, the cost to convert the vineyard posts to fence posts. This is actually done as a business in New Zealand. New Zealand wages are less than in Australia, so we reckon that's going to be a factor. Plus, you've also got to get them you get to where you're working and then distribute it out back out from there. So transport's a big issue. Yeah, what are the quantities of unusable posts and waste? And I suppose you can flip that round to what's the quantities of usable ones. Only a proportion of them. We've done some measurements because there's a minimum length, as you'd imagine. You can't have a really small fence post. We found that probably just on a length basis, you're looking at maybe 30% of them are rejected already. So the reason you want to look at this is because you're probably not going to be very popular with the vineyard owners if you go to them and say, I'll just pick through your pile here and just pick out the good posts. In New Zealand, they give them a price that the vineyard owner has to pay the fence post company to take the whole lot of them. And obviously that's got to cover the disposal of the ones that aren't any good. And it creates an incentive to the fence post manufacturer to make the best value out of this resource they've got. And mentions Eddie's touched on a bit of this, the acceptability of the post by fencing contractors and farmers. I suppose the issue is they have to have faith that, you know, they've gone to all this work to put it in, that it's actually going to give them a reasonable product. One of the incentives, of course, is to have a substantially lower price than the new post. And in New Zealand, it's less than half the price of a new post, but it still has to be fit for purpose. Last one is marketing and sales outlets. Obviously, people don't know about it. They're never going to be able to buy it. Sales outlets in the company in New Zealand have an arrangement with Mitre 10 there, where they sell them through the Mitre 10 stores, and we've been investigating that sort of option for Australia. Okay, I'll pass back over to Tripti to wrap the session up.
Thanks, Martin. Thank you. So just some of the next step, what we want to do, we still need to continue the data. Data is only good as it is current. So we are very, very mindful of that. And we want to collect on data on other unused resources like C&D waste, pallet, forestry biomass, allowing organizations to add their own layers on our map. So that can be confidential to that particular company or group that we're exploring as well. And we want to do a number of demonstration solution pilot in the future. We have mapped all the solutions and opportunities. What are the local solution? What are the global solution, which is currently not in Australia? How we can bring, so we are talking to various international industry partners, research partners, but all of these will require time, effort, and money. To finish off, reducing waste resource will not only cut the cost, but also support a more carbon positive future for Australia. Some of the recommendation what we have is to increase participation from industry for data collection and the data stewardship. Industry education in circular economy is another piece which is quite important. Further investigation on the infrastructure and logistic of recycled wood resources. And at the end, we want to have a product passport to help identify end of life, wood type, or treatment for separation. What are in future, what are the rules and regulation will be to be certified as a product which have the recycle element? How much can you claim? All those issues we are thinking. investigate market demand and acceptance for recycled wood product. So as I mentioned, the program is only currently funded for 3 years, which is finishing in April 2026. So we will be applying different funding sources, including FV. And so that's our plan. So now team will be happy to answer any question what you already had, or if you have question, just shout out. Yes.
Awesome. Thank you all so much. I was just wondering, what platform is that resource map hosted on?
It's hosted at the National Durability Center.
And like what technical?
Yeah.
ArcGIS. Cool. And you pay to host it publicly online?
A license, but if we continue, we'll probably need to get our own license. And at the moment, all of the tools that we've used are, all the tools that we've used to build the map are existing tools. So in the future, to make it even more user-friendly and do the things that we want to, we'll probably need to have our own license and design things for it.
Yeah, hi, Darryl Killen, a fascinating session. What do you think is the main obstacle to the circular economy actually getting a grip into the current economy? Is it the lack of actually having common metrics and understanding what the new market might look like, or is it a lack of penalties? I mean, for example, we tax smoking, alcohol, and gambling. Is it we're not taxing waste enough, or are the penalties not high enough, or is it too complex to sort of make it work? I'm just curious on your view around that.
I'll start, but I'm sure Martin will have a few things to say here. Look, I think it's a whole range of things, from the regulatory space to a lack of understanding through to our distance. Every time you take a piece of timber and have to process it, it's the labour that Tripti was talking about. So there's all of these things. But we don't have a lot of solutions either, particularly for treated timber. So it's just bringing all of those aspects together and building on them and showing the solutions and showing things like I told you how much people are spending on waste compared to the fact that they could be making waste. So yeah, I think there's an education point there as well. But I'll let Mark.
Does this work? Yeah. Okay. I suppose what I've seen is that this is just looking at broader circularity, not necessarily timber, is that governments are very pleased with themselves and just sort of grabbing onto those simple ones like deposits on cans and bottles and keep cups and all that sort of stuff. But when it gets to the deeper stuff, I think it needs more societal change. I think that's really the stumbling block, and it takes a whole lot of forms. There's one of the big ones, I suppose, is there has to be some acceptance that you are going to actually go down this path, and people are reluctant, like, oh, you've got this one, like these fence posts, for example. Is it as good as the other one? And I mean, and that comes into about this around the standards and stuff, so people have a bit of reassurance. I mean, there's just multitudes of them. There are products designed not to be repaired. There's and you're probably aware there's those right to repair movements and that sort of stuff. And also there's you might be wanting to repair the product and it might be repairable, but you can't get the parts, and there's no instructions. There's just a myriad of barriers, and I mentioned some of the regulatory ones as well. So, but I think the main one is unless you get a societal change that people say, yeah, this is what we want to do, it's not going to happen.
I'll just add to that if I can. The South Australian government has just given a fairly large sum of money to investigate product stewardship for treated timber. So there is movement there, and if there's a pot of money to actually deal with the unused resources at the end of life, it will make it a whole heap easier for entrepreneurs to come on board and start doing stuff with it.
Sorry, I was just going to add a little bit. Sorry,
Yeah.
Tripti. Yeah, well, Martin had the figure. I think he said 250. What did you say? 250 per ton. But it's actually substantially higher than that,
Yeah.
a little bit. Some up to $500 per ton or 520, something like that. I think we kind of averaged it out. But when you're saying like that, is there no, that's the way. So basically, there's a 10% increase. Most states are increasing by 10% every year to a particular cap, and that's kind of the incentive for finding solutions, is by continually increasing the price of landfill, so that there's other options. So rather than fining, it's more of a, okay, we're going to put this onto a business to find a solution. Yeah.
Yeah, so bottom line is that we only have limited amount of landfill resources and the prices are going up. And there are a whole lot of things what these people are saying, but economics is the biggest one. And then lack of understanding. So as more people are educated, productive stewardship pressure comes along with the economics, this thing will happen, circularity. Oh, Linda.
Hi, thanks for a really fantastic session. I feel really bad doing this, but I just want to be clear. I do feel terrible, but Penny, you made the comment that I made the comment that something about, circularity not being promoted. I just want to make sure it's not taken out of context. There are just some jurisdictions or countries or regions where they're not promoting circularity. So they're not using the word, which is why you'll sometimes see the word bioeconomy by itself. And I actually think this last question started to go into that. There's all sorts of reasons, I suppose, why a country, for example, wouldn't promote circularity. So I just want to make sure that it's not a blanket, it's not promoted, it's just in some places.
No, I just threw that out there because I actually thought it was interesting, because at that front end of the supply chain, the business is to grow trees to sell. So it is not in their best interest, obviously, to reduce their output, or it's probably in their best interest to have better output, at obtaining more money and using recycled timber for all of those lower value applications. But yeah, down the supply chain, there is incentive emerging.
I didn't want to make you feel bad. I just wanted
no.
I
sort of threw it out there because when you said that, I was like, wow, are there some
it's
people
fascinating, right?
Yeah. So, no.
And so I just wanted to actually pick up on something you just said about the innovation and sort of entrepreneurship that's required to sort of make that stepwise change. I'm just wondering if any of you have any comments around, Tripti, you commented on the economics and the landfill filling up and that sort of being, incentive, but just any of the sort of enablers or anything that you think would help boost that sort of innovation and entrepreneurship in this space. You might not have an answer because I know you didn't, but I'm just curious after all the discussions you've had.
Yeah. Oh yeah. Oh, sorry. I was just one step back about some people promoting, or some regions or jurisdictions promoting circular economy and some not. The same is within Australia. So when I mapped the circular economy council areas, they were areas that actively promoted circular economy on their websites or their action plan, or and so it's not saying that others aren't thinking about it, but it's not prominent in their day-to-day terminology. And in some of those circular economy initiatives, those places that have a circular economy initiative also promote innovation. So some have actively saying we are seeking businesses and we're supporting businesses who want to come into this region. And but I don't know. We don't know detail. I don't know details of them, but maybe Tripti.
I mean, we are talking to a number of entrepreneurs. They are really new to all this circular economy. It's really fascinating, but they are willing to take gamble. They just need bit of support, bit of financial support, and that's where it doesn't match, because they are entrepreneurs. They don't have a big company industry. They are individuals, but they think it's a really good idea to get into it, but they just don't have the capital. And so that, I mean, if we can engage government or someone who could support them, that could be one of the ways. Yeah, Penny talks to them all the time. So,
well, I was just about to say around that. We've been talking to one particular group with a solution that are based in Adelaide, and they've been talking about this solution now for 3 years, or well, way probably before we met them, and they realised that there wasn't enough resource where they wanted to set up. So basically within 8 weeks, they would run out of this resource. Anyway, they recently looked at our map and they went, oh, in Western Australia, they've got this other resource that could support that, and why don't we set up there? And if they set up in Western Australia, there'll actually be a fully circular economy as well, because there's other businesses there that will take what they're producing, so it will make that fully circular. So that leap from we've got this solution, we don't have enough resource, we don't have the money to get started, but if we go here, then those people will buy the heavy metals that we extract and do this. So I think joining the dots with circularity is quite key. And Europe is probably very different because of the distances. Like we've got the resource, but it's so dispersed that it's problematic. So I don't know, Martin, did you want to?
And it's quite actually encouraging, like big companies. So Borg is the biggest particle board manufacturer in Australasia. And only within the last 2 years, they were like using recycled timber only 10 to 20%. Within last 2 years, now they are up to 65%. So they are doing, big companies are doing. And there was a question actually through app about the pallet. So the Borg, that's their model. They have pallet collection in the 400-kilometer radius to their facility, and they collect pallet, and they actually, one of their subsidiary redirect. Some of the pallet which are in good condition, they resell it. The other, which is in not good condition, they make it cheap and use for the particle board. So it's happening. Someone had asked that whether we will consider mapping the pallet. We will, that's our goal. But I feel like that the Borg is already doing in their areas. And if someone set up another particle board or Laminex kind of facility, they would be doing the same in other areas.
Can I just say about the pallets, we have actually been talking to one of the major retail groups who have 300 odd stores all around Australia, and they go to such dispersed places. So each retail store might end up with 2, 3, 4 pallets, and some might end up with 60. So again, the solution needs to be very regional. So in some places, yes, you can burn it as energy because they've got these multi-million-dollar energy facilities, and Borg has their amazing facility. But in other places, we really are going to have to think of very small regional solutions for things like that.
Yes.
Oh yeah, well, we're already seeing it. We've had a few case studies where somebody's asked for the wood waste, and then the frame and truss companies have gone, well, how much are you going to pay for it?
Yeah.
But they're already paying to get rid of it. So that's what I said about Mega Beam. Like, that's a win-win situation for both of them, because one of them doesn't have to pay for the waste disposal and one of them doesn't have to pay for the resources. But as soon as that, like if the frame and truss offcut said to Mega Beam, you need to pay us now, it would not make financial sense for Mega Beam to do that anymore. So
it was such a funny story. I was invited to give a presentation at Murray River vineyard kind of place. So initially, when I went there, they were so angry, group of farmers and all that. Why you guys have been working and you haven't come to the solution, this and that. When I presented and showed the stuff, then they said, we just want to get rid of it. After my presentation, they said, I'm not going to give free. I can make money out of it. Immediately, within 1 hour, that's changed their stance. Yeah. Yes.
Okay.
Sorry.
Sorry, I just got a couple of quick reflections picked up on that. One of my learnings last week was, and it sort of fits into the discussion here, Tim Woods presented last week, and the usual stuff talking about the amount of, we need to move a lot of our house construction to factory-based things, which really does lend itself to engineered wood products, and you focus there. But the figure that stuck in mind, I hadn't heard before, is he said currently with current brick veneer housing and framing, 30% of the actual wood that we take to a building site ends up in the skip bin and generally off to landfill. All the cuttings and stuff, they get delivered to 6 metre lengths, and by the time they cut it up and put it into a house, 30%, which is a huge figure.
Can I just comment on that?
Yeah.
Well, the other issue with that is if it's in a factory, it's really easy to collect the timber. As soon as it goes out onto site and it gets in with a whole range of other, debris it's literally impossible to sort out. So there is other benefits to doing those.
And the best example I've seen of that in recent years was over in China, in Guangxi, and an industrial estate where they had a whole lot of those little spindleless lathes, but they already had an existing small MDF plant, and then they put in particle board plants, veneer plants, and I guarantee you that 99% of every bit of fibre that went over the fence there ended up in one of those plants, right down to the sandings off the veneers went into the fine layer on the particle board. Was passed over the fence to the next person bought it. So that was the best example I've seen. And Mark.
And then the product comes back to Australia.
Yeah. And Martin, one of the other reasons why vineyards, I think, owners are pulling out CCA posts with any sort of damage, it's just the move to organic wines. Organic status. And this is probably why I was first alerted to this by Paul Millen in New Zealand and around the main Sauv Blanc region in the north there. As soon as they break a post, they're not allowed to replace it with a treated product. So that has actually created now a whole group of durable eucalypt growers. Paul established a program in New Zealand. It's been breeding and working up stuff for about 15 years now, but we've got great examples here in Australia of growers now are banding together between ash timbers and heartwood in Victoria and super forest plantations and Herefords in northern New South Wales to move to a durable untreated product, which again I think fits in nicely to this whole story. It'll be much more easy to recycle that material.
If we had access, that would be wonderful. But what the wineries seem to do is transition to metal posts. Yeah. And so there hasn't actually been a life cycle assessment done on timber compared to alternatives in vineyards. But from other life cycle assessments, we can see that even with the treatment and end of life issues, the timber posts are still, a better environmental alternative. So yes, if we had access to hardwood posts, that would be great.
Thank you for your presentations and talks so far. My question may not really sound very sound, but just out of curiosity, I'm wondering if there are available life cycle assessment data on reused timber as to probably how much of difference would it be from fresh, timber source in terms of probably their mechanical behaviors, and how probably this could promote interest in reusing timber more. I'm just wondering whether there's often life cycle assessment or data available to actually see how much of difference it will be in reused timber compared to virgin timber, fresh timber, and how mechanically durable and the likes they could be. Yeah, thank you. And possibly if there are specific economic tree species or economic timber that have higher durability of reuse and recycle compared to specific species, and if there is a list or probably a compendium of these particular species that we should focus on in timber circularity discussions. Thank you.
I can't comment on the second one. Tripti will have to do that. But the life cycle assessment, it's a really great idea, and I haven't seen anybody look at that yet. So might be something that we can build into a future project, because I think it would be very interesting to better understand the life cycle comparisons between new and recycled. So thank you.
Yeah. So your question about the which timber species and things like that for vineyard post specifically, you ask?
Yeah, not necessarily for vineyard or for any products, but if there is already studies or identification of specific timber species that have high potential recycle and reuse opportunities and benefits.
Yeah. In Australasia, we have the durability classification. So 1 to 4 classification, and these in the building product, you can use Radiata pine, for example, or other pine species, which is very low durability. But you have to either modify it or treat it. Some of the other eucalypt species you can use, and eucalypt species have a huge variability and variety. Some of them are very durable, so you don't need to use any treatment, anything. You can use it for ground contact or in the building. And obviously they will have a probably better life cycle because you're not using the elements of chemical, and so no handling and those kind of thing. But the problem is that we don't have that many the resources is not there. So we end up using likes of pine species and treating them. Yeah, you can talk to me later about the durability.
Obviously a really important project and something industry has needed for a while. And I guess you did touch on regulatory environment. So once we get all the technical and logistics, one of the issues we have in Queensland is the regulation. And you'll be aware that the end of waste code process is laborious and under-resourced in the state, and every industry has complained about it. We've got one end of waste code for treated timber in Queensland, maybe 1.5, and that's been 5 years of work with the state government. And I guess having data really helps, but I guess it's that regulatory environment. So maybe if some comments on that. We know it's been a real barrier in Queensland.
I'm going to hand the mic to Martin. Oh, you go. Yeah, he's just finished our regulatory reporting. Yeah. So
the Queensland model, I wasn't aware of the under-resourcing bit, but just that model, the end of waste code. Other states are certainly eyeing off something similar, because it is light years ahead of what you've got at the moment, where some of them are sort of like deliberately say you just can't use it. Some of them just leave it as a grey area, whereas the end of waste code says, under these conditions you can do X with Y, and that's just so clear cut. I suppose New South Wales is the closest to that, but and they're actually thinking of moving to end of waste code, but they have a system whereby they have a set of public statements where they're like end of waste codes, but they've also got an unknown quantity of private ones that are completely confidential. So in theory, you could have multiple companies going and asking for exactly the same thing because they're not aware of the other ones that are out there to use as a model. And I think that system is not ideal. It's much better to just have the published end of waste code. Everybody knows about it.
So Mick, you may think that the Queensland Waste of Code is no good, but other states are worst.
Yeah, exactly.
Yeah.
Yeah.
Mm. Mm. Yeah. Yeah. Mm. Yeah. And that's why we did the retention and strength data, because that was one of the things the regulatory authority was asked. Well, it's no good. Well, we have shown that it's still good after 30 years. So, yeah, yeah, sure.
And just build on.
We'll build that into our next proposal.
So just build on that, Mick. The Australian New Zealand Industry Biochar Group's got their 2030 roadmap. I'm assuming you intersected with them, but just noting that they have the same issues with the butterfly diagram, the same issues with the circularity, the same issues with the end of waste code. It just seems to me like we just need to get the biochar, ANZBIG, probably forestry and carbon sectors all to sing the same song at the same time to the same people in the government to try and push the things through, because it's just, I could be at the ANZBIG conference here and talking about exactly the same things.
It's getting that message clear, isn't it? If we're all sending that same message, it will get through. Whereas if everybody's got their own language and what they're saying, it's a bit more problematic. Sorry, what was that? Yeah, well, one of the guys that wrote it was actually was on the project for a bit, so we had quite a bit of discussions around that, and he helped put together the ANZBIG proposal. So the other thing that you might want to know is we do actually have all that regulatory stuff up on our website now, so you can just go to the timbercircularity.com.au website and find that. Yeah, and it's state by state, so you can search.
Mm. Yeah. Mm. Yeah, something at the Forestry Australia conference or something, we can have a session or something like that. Yeah. Cool. Thank you, everyone. Well done.
Thank you. Can you grab mine as well? Thanks.
I think we have afternoon tea now,
Oh.
and we'll be back at 3.
Very interesting.
question. People really, absolutely.